All right, Mr. Trutna here. So here's what we're going to go over today, and these will be the notes that you would take on how to find volume. Let me pull this down a little bit so you can see it. So how to find volume of prisms. Okay, so there's two things that we're going to go over today. We're going to go over what exactly is volume. Actually, three things, excuse me. What exactly is volume? What exactly is a prism? And then lastly, we're going to introduce how do you find the volume of a prism. Okay, so if you were taking notes, you would want to be writing this stuff down. So the first couple things that we're going to talk about are just going to be definitions. So the first thing is, let's talk about what is meant by when you're asked to find the volume of a shape. Okay, so volume is the number of cubic units that can fit inside an object. Okay, that's what volume is. I think the key word in this is inside. So when you're asked to find volume, or when you find volume of a shape or an object, you are telling, and you get an answer, you are saying, the answer tells you how much can fit inside the object, and that how much is always measured in cubic units. Okay, so if I wanted to know, let's say I was holding a Gatorade bottle, and I said, I wonder how much sand would fit inside this Gatorade bottle, you would be finding the volume of that Gatorade bottle. Okay, so how much fits inside a shape or an object, that's what volume is. Okay, the next definition is, and we're going to talk about this particular object today, is a prism. And a prism, and this is a very loose definition, so I did not even look this up on Webster's dictionary, but a prism is a three-dimensional object. Okay, so it's three-dimensional. It's a three-dimensional, and the abbreviation, as you guys all know, for three-dimensional is 3D. So it's a three-dimensional object that has two sides that are congruent. And remember, that's the abbreviation for congruent is that right there, comma, parallel, and the abbreviation for parallel is that symbol right there, and are polygons. Okay, so a prism is a three-dimensional object that has two sides that are congruent, parallel, and are polygons. So in order for something to be considered a prism, four things have to happen. First thing is, it has to be three-dimensional. A shape cannot be considered a prism if it's not three-dimensional. So it has to be three-dimensional. And then the other thing that has to happen is two of the sides of the shape or the object have to be congruent, and they also have to be parallel, and they also have to be polygons. Okay, congruent means they have to be the same. Parallel means that they will never ever touch. And then a polygon means it has to be a shape that is not a circle or not an oval. Okay, remember, polygons are your normal shapes that you're used to seeing: rectangles, squares, triangles, pentagons, hexagons, octagons, that sort of stuff are polygons. Okay, and so these three things have to happen, along with it being a three-dimensional shape, for it to be considered a prism. Okay, so what I'm going to do here is I'm going to draw you two examples of prisms, and then we're going to kind of break down why these two examples are considered prisms, and then we're going to kind of name some of the special pieces of it. Okay, so as I'm doing this here, I'm freehand sketching, so notice I'm not using a straight edge. And so if my shapes look like they're a little bit off when I'm done, don't be too quick to judge me. I'm doing the best that I can, and I'm just kind of eyeballing, and I'm just kind of freehand sketching as I go. Okay, so this is how I make prisms. I draw two shapes like that, and then I just connect the corresponding corners to each other. This is how I found that it's the easiest way for me to do it. Some people draw prisms a little bit differently, but that's how I create my prisms right here. Okay, so that would be my first example of what would be considered a prism. So this object right here is indeed a prism. And my other example is going to be a little bit different, but this other example would be something that if you go camping, hopefully you bring with you. And if you don't bring it with you, you would hope for good weather, because you wouldn't want to be without one of these if it was rainy weather or something like this when you were camping. Okay, so I'm going to connect the corresponding corners to each other, like that, like that, a tent. So both of these are considered prisms. Now let's talk about why both of these are considered prisms, okay? So in order for something to be a prism, it has to be three-dimensional. So let's talk about this one right here. This one is three-dimensional. And then two of the sides have to be congruent. They also have to be parallel, and they have to be polygons. And if you notice, and I'm just going to pick two sides that are congruent and also parallel, if you notice, the front of this shape, this prism, is congruent to the back of the prism, and I'm shading them in so you can see it. So notice that those two right there, they are congruent to each other, they are parallel to each other, and they're also polygons. They're rectangles. Rectangles are polygons. Okay, so this shape right here, by the definition that I gave you, would be considered a prism. Okay, now if we go over to the tent looking shape, if you notice, the front of it, the triangle, so the front triangle, is exactly the same as the back triangle. That makes them congruent. The front and the back will never intersect each other. They'll never touch. So that makes them parallel. And triangles are polygons. So this would be considered a prism as well. Okay. Now the exact name for, let's go over here, the exact name for this prism right here would be considered a rectangular prism. And the reason why it's called a rectangular prism is because the two sides that are congruent and parallel are rectangles. This shape right here, if I said what kind of prism is it and you were in the classroom, hopefully you would give a shout out for triangular or triangle prism. This would be considered a triangular prism. Okay, so that's how we would name these shapes. Now, it's not that necessary that you know exactly how to name prisms, but it's necessary that you know why both of these are called prisms. Okay, all right, so now let's switch over here and let's talk about some terminology that we use for prisms. Okay, so I'm going to introduce two terms for you that you're going to hear me say quite a bit as we go into this prism things here. So the first thing is, the first terminology is the bases. You need to know what is meant by the bases of a prism. Okay, and the bases are the two sides that are congruent and parallel. All right, so in this rectangular prism, the bases would be the front and the back. In the triangular prism, the bases would be the front and the back. And I did this on purpose because I want you to be acutely aware of the fact that the bases aren't necessarily the bottom of the prism. In both examples that I drew, the two bases are not the bottom. So don't, in your mind, just naturally assume that the bases are the bottom. That's a common mistake. And remember, there has to be two bases in order for the shape to be a prism. They have to be congruent and they have to be parallel. They also have to be polygons. Okay? And then the other terminology that I'm going to bring to you is the height. Now, a lot of you guys might be thinking, yeah, Mr. Trutna, I know what the height is. The height is how tall something is. Okay, but it's a little misleading as to what the height is of a prism. So the height, when we're talking in terms of a prism, is any segment that connects the two bases. Okay? So any segment in your object, any segment. So there could be more than one height in an object. Any segment that connects the two bases would be considered a height. So that means in my triangular prism, this segment right here, going along the bottom there, it connects the two bases. The bases are the triangles, so that would be considered a height. This segment right here would also be considered a height. And even this segment in the back that's dashed, it would also be considered a height. Okay, so this triangular prism actually has three different choices for a height. Now, they'll all be the same. They're not going to be different measurements, but there's three different segments that represent the height of this triangular prism. When I jump over to the rectangular prism, this segment would be considered a height because it connects the two bases. This segment would be considered a height. This segment would be considered a height. And this segment would be considered a height. So in the rectangular prism that I drew over here, there are four possibilities for a segment that would be considered a height of this prism. Okay, they're all going to be the same, but there's four possibilities you have. Okay, all right, so there we go. There's enough of our definitions and our terminology. Now let's get into the really heart of the lesson is finding volume of a prism. Finding volume of prisms. Okay, now here's the cool thing about it. To find the volume of a prism, there is a formula that works for any type of prism. So as long as a shape is considered a prism, there is one particular formula that will always find the volume of that prism. And the formula is area of a base times the height. Okay? Notice the formula says area of a base. It doesn't say the area of both bases. So to find the volume of any shape or object that's considered a prism, you find the area of a base, of one of the bases, you multiply it by the height of the prism. Okay? And if you were reading this in a book, they would write the formula like this. They would put capital B times H. So what does capital B stand for in the formula? That stands for area of a base. That's how they represent area of a base in the formula. And then the lowercase h, notice it's not a capital H, it's a lowercase h, represents the height of the prism. Okay? So that's the formula. Now the cool thing is, like I said, that formula works for any type of shape that's considered a prism. So if I said find the volume of this rectangular prism, you would use this formula, area of a base times the height. If I said find the volume of this triangular prism, you would use this formula, area of the base times the height. And what we're going to actually do indeed is we're going to find the volume of each one of these prisms right here. And I'm going to walk you through it. Okay, so the first one right here, a rectangular prism. So I'm going to do my absolute best here to recreate the rectangular prism, and it doesn't have to be exactly the same as it is up there, but there's going to be a striking resemblance to both of them, much like there's a striking resemblance with Mr. Kendall and James Franco. Connect all the corresponding corners or vertices with each other, and there we go. Alright, so let's go ahead and make this line segment here 10, and let's give it a measurement. Let's do centimeters. Let's make all of our measurements in centimeters. Then let's give this part right here a measurement of 8 centimeters. And then let's give this back segment right here a measurement of 3 centimeters. Okay, so what we're going to do here is we are going to find the volume of this shape. Okay, so here's how I would suggest when you find the volume of the shape. The first thing that you want to do is you want to identify the bases. Okay, and then what you want to do is, after you identify the bases, I think it's always a good idea to make a drawing of a base. It's going to be very important to do that. Okay, so remember, a base by definition is it's going to be, the bases are going to be two of the sides that are going to be congruent and parallel. And we have a couple choices here on the two sides that are congruent and parallel. But let's go ahead and let's just be consistent with what we did earlier. So let's denote the bases as these two sides right here. So those two sides would be called the bases right here. Now, just for terminology, 8 is considered the length of the prism. 10 centimeters is considered the width, and 3 centimeters is considered the height as we drew it here, but that's going to be a little bit different when we find the volume. Okay, so how do we find the volume of this shape? We're going to use this formula. Volume is capital B, remember capital B stands for area of a base, times lowercase h, and lowercase h stands for the height of the prism. Okay, so first of all, my suggestion is, somewhere when you're finding volume of a shape, make a drawing of one of the bases. So we have denoted that the bases are going to be the front and the back of this prism. So those are rectangles, so go ahead and make a drawing of a rectangle and denote how long the sides are of the rectangle. So notice in the front rectangle, the bottom part is 8 centimeters. And then this line right here is that line, which is the same as that line, so it has to be 3 centimeters. Okay, now why is that important? I think that's important because it gives you a visual. So to find the volume, what we're going to do is we're going to find the area of the base. Well, this shape right here is the base. It's a rectangle. How do you find area of a rectangle? Simple. You multiply the two sides together of a rectangle. So area of this base would be 8 times 3. And that's equal to 24. So my area of my base is 24. And then I'm going to multiply it by the height, and it's going to be the height of the prism. So don't think the height is 3. Okay? The height of the prism, remember, is any segment that connects the two bases together. So this segment connects the two bases together, as does that segment, as does that segment, as does that segment, right there. So how long are any one of those segments? Those are 10 centimeters. So the height of the prism is 10. So multiplying those two together, we would get 240. So the volume of this prism is 240. Now, what is it? It's 240 what? What are the units that we have? Okay, so if you think about this, how did I get 24? Well, I multiplied 8 centimeters times 3 centimeters. And then I multiplied that by 10 centimeters. So that's where the 240 came from. 8 times 3 times 10, 240. And then, how many centimeters do I have? Well, I have 3 of them. So that means, and the way I express that is I'm going to have centimeters to the 3rd power. And we call that cubic centimeters. So the volume of this prism would be 240 cubic centimeters. Okay? And that would be how we find the volume of that particular prism. Now let's go to the next one. Let's find the volume of the triangular prism as well. Okay, and I'll go ahead and I'll try to squeeze it in down here. I think I can do it. If I draw a little bit smaller, pretty sure I can manage to do it here. Okay, so I'm going to draw, I'm recreating this triangular prism again. And once again, since I'm recreating it, it's probably not going to look perfect. But I've had some practice doing this. And so then I connect the corresponding corners to each other, or the vertices. And you will notice sometimes there's dash lines. And the dash lines, what they indicate are the lines that are hidden behind the shape. So if you were looking at this shape, you wouldn't actually be able to see those dash lines, but they're there. Now I did not do it in this prism here, but I did it here. Okay, so I want to find the volume. Oh, let's give some measurements. Okay, sorry about that. Can't find the volume if you don't have any measurements at all. So we got to give you guys a little bit of information here. So let's go ahead and put 10 centimeters right here. Let's go ahead and make this 18 centimeters long. And then I'm going to draw a line segment in this back triangle from the top of the triangle straight down to the bottom, and I'm going to put a 90-degree angle there. And that's going to be important. And I'm going to draw a little arrow here because I don't think I could squeeze it in. But let's go ahead and make that 4 centimeters long. Okay, so I'm going to find the volume of this prism. So the formula to find volume of any prism is capital B. Capital B stands for the area of a base, one of the bases, times lowercase h. Lowercase h stands for the height of the prism. So area of the base times the height. Okay, now, like I said, I think it's always a good idea when you're finding volume of prisms, make a drawing of a base. Okay? And that's going to be important because we're going to have to find the area of a base. So what's a base? Remember, a base, once again, is the 2 sides that are congruent and parallel. So that would be these 2 triangles here. They're the only 2 sides in this shape that are congruent and parallel, so those have to be the bases. So what you want to do is you want to draw one of those 2 and then fill in all the information that you have. Okay, so I'm going to draw a triangle here. You will notice the bottom of the triangle, either triangle, it doesn't matter, they're the same, is 10 centimeters. And then the height of the triangle, oops, kind of drew it from the wrong corner there, the height of the triangle right there is 4 centimeters. Now it's going to be important, okay, because the formula says I have to find the volume, I have to find the area of the base. So I have to find the area of this triangle. Okay, so how do you find the area of a triangle? Well, you got to remember the formula. So to find the area of the triangle, you take the base of the triangle, which is 10, you multiply it by the height of the triangle, which is 4, and then you divide it by 2. 10 times 4 is 40, 40 divided by 2 is 20. So that means the area of the base is 20. And then you multiply it by the height of the prism. Now, a common mistake is people would say the height of the prism is 4. That's not true. The height of the base is 4, of this triangle is 4. Remember, the height of the prism, if I go back up here and look at my notes, is any segment that connects the 2 bases. So that means this segment is a height of the prism, as is that segment, as is this broken segment in the back. And they're all going to be the same. And how long are they? You can see they're 18. So the height of the prism is 18. 20 times 18 is 360. So that means the volume of this particular prism would be 360. Now you just don't want to say 360, you have to include the proper measurements. Okay, so if you think about it, how did I get 360? Well, I multiplied 20 times 18. How did I get 20? Well, what I really did was I multiplied 10 centimeters by 4 centimeters, and then I divided it by 2, and then I multiplied that by 18 centimeters. So 10 times 4, 40, divided by 2 is 20, that's where 20 came from, times 18, that's where 360 came from. I have centimeters, centimeters, centimeters. So how many centimeters do I have? I have cubic centimeters. I have 3 of them. So my volume would be 360 cubic centimeters. Or you can say this as centimeters cubed. It doesn't matter which way you say. Okay, there we go.